الحمد لله رب العالمين، والصلاة والسلام على أشرف المرسلين وعلى آله وصحبه أجمعين. Overview of Air Pollution by Professor Mahmoud Hani Sulaiman, Al-Azhar Faculty of Medicine. This talk will give an overview of air pollution, will mainly focus on common outdoor air pollutants and indoor air pollutants, discuss types of air pollutants, discuss sources of air pollutants, discuss health effects and environmental effects of air pollution. Air pollution, the problem: global ozone layer depletion, greenhouse effect, regional, acid rain, haze and photochemical smog, local, indoor, homes, factories and offices. Air pollution, the problem. There is global, regional, local and indoor air pollution. Global: upper atmosphere ozone depletion, climate change due to greenhouse effect, regional, acid rain and photochemical smog and haze, local, SO2, lead and particulate matter, local also, air toxics, indoor, particulate matter, nitrogen dioxide, air toxics and biological pollution. Effects of human activities on atmosphere. As you see, this is the greenhouse effect. On your left side is ozone depletion. Ozone destruction by chlorine and bromine allows more ultraviolet radiation to reach the earth, and the adverse effects of UV. Greenhouse effect: some long-wave radiation is absorbed by greenhouse gases and re-emitted to the earth, leads to increased warming. The enhanced greenhouse effect. Air quality: in the presence of sunlight, reactions between volatile organic compounds and nitrogen oxides can lead to the formation of smog. The picture is very representative. Ozone layer depletion. Stratospheric ozone reduces harmful UV radiation. Chlorofluorocarbons, methyl chloroform, carbon tetrachloride, halogens, methyl bromide, Montreal Protocol on substances that deplete the ozone layer. Postulate steps from the release of halocarbons to increase in UV related to biological damage. Halocarbons release chlorine and bromine radicals. This will lead to chlorine and bromine radicals destroy ozone molecules. Then stratospheric ozone layer depleted. Then increase in UV radiations at ground level. Then increase in ultraviolet related biological damage. Greenhouse gases. Naturally occurring gases, CO and methane. Man-made gases, CO2, nitrous oxide, chlorofluorocarbons. This scheme shows that incoming sunlight is absorbed and released. Infrared radiation goes back into space, but some is trapped and so increasing the temperature. Global warming. Global warming potentials of greenhouse gases: carbon dioxide, methane, nitrous oxide, chlorofluorocarbon 11, chlorofluorocarbon 12, hydrofluorocarbons, sulfur hexafluoride, other perfluorocarbons. Acid rain sources. Emissions of oxides of sulfur and nitrogen produce acid aerosols, H2SO4 and HNO3, also regional pollutant. Coal-fired and oil-fired power plants. Very important health effects of global environmental changes. Adverse effects on human health caused by global environmental change. Enhanced greenhouse effect, stratospheric ozone depletion, acid aerosols. Enhanced greenhouse effect will be manifested by global warming and other climate change, sea level rise. Global warming will lead to heat wave related illness and death, extension of vector-borne infections, altered variability of edible fish in warmed oceans, sea level rise, natural disasters, increased risk of flash floods and surges, will lead to social disorder, impaired sanitation, farmland loss, consequences of damage to foreshore facilities, roads, destruction of wetlands, which will lead to decline in fish stocks. Stratospheric ozone depletion, increase UV ultraviolet. This will lead to sunburn, conjunctivitis, suppression of immune system, increased risk of infection. Skin cancer, ocular effects, cataracts, pterygium, impaired growth of food crops and of marine microorganisms. Acid aerosol will lead to acid rains, effects on respiratory system, query, aquatic damage, impaired forest growth. Continued land degradation, intensive agriculture, overgrazing, manifested by erosion, sterility, nutrient loss, salinity, desertification, depletion of underground aquifers. Type: direct early decline in agricultural productivity, lack of water for drinking and hygiene. Late direct rural sector depression leading to migration to fringes of cities. Decline in agricultural productivity, early indirect exposure to pesticides and fertilizers, late indirect consequences of silting up of dams and rivers, loss of biodiversity, and other effects of overpopulation, particularly in poor countries. Regional local air pollutants criteria: common air pollutants, ambient air quality standards established, regional photochemical smog, ozone, haze, particulate matter, and nitrogen dioxide, local sulfur dioxide, carbon monoxide, lead, air toxic, often no standards. Air toxics or hazardous air pollutants definition: gaseous aerosol or particulate pollutants other than the 6 criteria pollutants that are present in air in low concentrations with characters as toxicity or persistence to be hazard to human, plant, or animal life. Air toxics, very important, diverse range of toxic compounds, volatile organic compounds, persistent organic pollutants, polycyclic aromatic hydrocarbons, toxic metals as arsenic, cadmium, lead, mercury, nickel, chromium, persistent bioaccumulate, toxic kidney, liver damage, CNS disorders. Air toxics, diverse range of point and diffuse sources. Point source as industries and other facilities emitting in a localized area. Diffuse source, mobile sources as road vehicles, area-based sources as wood burning. Indoor in-vehicle exposures, increasing regulatory public concern, generally little or no exposure data. US EPA list of 189 in 1990. List of priority hazardous air pollutants. Very important. Benzene, 1,3-butadiene, polycyclic aromatic hydrocarbon, arsenic and compounds, chromium and compounds, nickel and compounds, cadmium and compounds, dioxins and furans, mercury, dichloroethane, formaldehyde, styrene, 1,4-dichlorobenzene, tetrachloroethylene, manganese compounds. Indoor air pollution. Indoor air defined as any non-industrial indoor space where person spends period of an hour or more. This can include airspace in office, classroom, motor vehicle, shopping center, hospital, and home. Quality of indoor air is influenced by two major factors: amount and quality of outdoor air, sources of air pollutants. In winter, 80 to 90% of time spent indoor. A number of important indoor air pollutants, particles, environmental tobacco smoke, oxides of nitrogen, formaldehyde, biological pollutants, house dust mites, molds, etc. Relationship between indoor and outdoor concentration of air pollutants, they are very close to each other, as shown by this table. Find particle levels by number of smokers in house. Increase of number of smokers will lead to high increase in level of indoor air pollution. Find particle levels by main heating type of heating affect level of indoor air pollution. Average weekly nitrogen dioxide levels in homes. Heating is the main source of indoor air pollution. Burden of diseases attributable to indoor smoke from solid fuels, DALYs in each sub-region, as you see where Egypt. It is a risky situation. Ambient air pollution. This is an example of urban air pollution. This is an example of rural air pollution. This is an example with pollution and without pollution places, the same place. Historical perspective of air pollution. Several air pollution episodes occurred everywhere. In London, England from 1952 to 1962, the most famous episode in December 1952, responsible for about 4,000 deaths. This is London smog and deaths. Early control measures, governmental regulation, standards to establish safe threshold, control strategies to reduce or prevent the increase. National Environment Protection Standards for ambient air quality. These are permissible levels, upper permissible limit for these pollutants. 6 pollutants: carbon monoxide, nitrogen dioxide, photochemical oxidant, sulfur dioxide, lead, particulate matters. It is measured, and if it exceeds this, prompt measures are taken. Primary secondary pollutants. Primary pollutants are particulates, nitrogen oxides, sulfur dioxide, carbon monoxide. Secondary pollutant, ozone and particles, gaseous pollutants forming aerosols. Air pollution concentration. Complex interaction influences quantities, rates, meteorological conditions, chemical reactions, and topography. These are factors interacting together to cause air pollution. Sources of air pollution: mobile sources, industry sources, and area-based sources and small point sources. Mobile sources, industry sources, area-based sources. Importance of air pollution affects large number of people. Involuntary exposure, health costs are enormous. Affects health of flora and animals. Health benefits from air pollution control, decrease road trauma, increase physical activity. Contribution of air pollution to the global burden of disease. In developed and developing countries, as you see, in developing countries, it is more. It is contributed to malnutrition, hygiene, tobacco, alcohol, and air pollution. Burden of disease attributable to urban air pollution. Again, look where Egypt is very risky. Role of air pollution in chronic disease. It aggravates chronic disease. Environmental and human health effects of major air pollutants. Ozone, NO3, carbon monoxide. Ozone damage to vegetation, decrease plant growth and crop yields, increase susceptibility to pests. Long-term low-level exposure is of concern. Damage to fabrics, rubber, and construction materials. In human health, ozone irritation of eyes and air passages, decreased pulmonary function, lung inflammation, sensitivity of asthma patients to asthma triggers, increased susceptibility to infection. NO3 damage to leaf surface, decreased plant growth. On human health, decreased lung function, lung inflammation, increased sensitivity of asthma patient to asthma triggers, increased susceptibility to respiratory infection. Carbon monoxide, decreased capacity of blood to carry oxygen, lead to decreased exercise capacity and aggravation of CV disease. Sulfur dioxide on environment, plant damage, growth inhibition, acid deposition, acidification of solids and lakes, change availability of minerals to plants, corrosion of construction materials. On human health, decreased lung function, lung inflammation may provoke wheezing and exacerbate asthma. Fine particles, reduced visibility, increased rate of respiratory illness and symptoms, decreased lung function, increased mortality due to heart disease and lung disease, increased symptoms of asthma patients. Lead can accumulate in soil and food chain in children, impaired intellectual development, increase human blood pressure and impair renal function. Air toxics, possible bioaccumulative effects from accumulation in food chain, and long-term health effects even at low concentrations, compounds, carcinogenic, mutagenic, teratogenic, and neurotoxic. Particulate matter health effects. Acute effects, decreased lung function, increased respiratory symptoms, increased hospitalization, increased mortality, increased plasma viscosity, heart rate variability. Chronic effects, increased mortality rate, increased chronic cardiopulmonary disease, decreased survival time, decreased lung function. Ozone acute health effects, increased respiratory symptoms, asthma attacks, decreased lung function, increased restricted activity days, increased hospital admissions, increased mortality. Nitrogen dioxide health effect, decreased lung function, increased respiratory symptoms, increase in hospital admissions, asthma, COPD, increase in mortality. Potential human health effects of nitrogen dioxide. Health effect, increased intensity of respiratory infection, increased severity of respiratory infection, increased respiratory symptoms, decreased lung function, worsening of clinical status of persons with asthma, chronic obstructive pulmonary disease, or other chronic respiratory conditions. Carbon monoxide health effects, increase of angina and ischemic heart disease, hospital admissions, heart disease, asthma, mortality, all-cause, and heart disease. Sulfur dioxide, decreased lung function, increase in symptoms of respiratory disease, increased hospital admissions, increased mortality, all causes, and respiratory and CVS. Health outcome measures in studies of air pollution. General, respiratory, and neuropsychological. General, respiratory, and neuropsychological. Please read it. Some other health endpoints of interest: cardiovascular disease, perinatal outcomes, cancer incidence, especially lung cancer. Some issues in air pollution: multi-pollutant exposure, low-dose exposure, size and composition of particles, threshold effect, shape of the response function, time activity patterns, confounding by season and weather. وأقول الحمد لله و thank you for your good listening.